Did you know that 40% of all food produced in the United States is wasted? That's 133 billion pounds of fruits, vegetables, meat, and fish that could be used to feed the 42.2 million Americans who live in food insecurity. Wasting food leads to a loss of $161 billion annually in the United States. Food can be wasted on farms, in houses, at grocery stores, or in restaurants. The majority of this food gets thrown into garbage bins and is never given a second thought. But what happens if we were to do something different with those food scraps? What if we changed the norm? What would happen if everybody in America composted? In today's society, people go to the grocery store, buy foods ranging from processed frozen meals to fresh fruits and vegetables. They consume it and throw the scraps away in the trash. There is no questioning where the food comes from or where it goes. By throwing food away, people are disrupting one of nature's processes of breaking down organic materials and returning the nutrients to the soil.
Because when you divert food waste from the landfill and put it into a compost pile, well, right away you're doing a good thing by not taking up useful landfill space with something that can be rotted and used again on the farm. So when organic material like food waste goes into a landfill, it'll generate methane. And that can be a good thing if you're trying to make energy from a landfill. Some modern landfills will capture that methane and burn it. But a lot of the older landfills, they just are generating methane as a greenhouse gas pollutant.
Methane is a potent greenhouse gas that is 28 to 36 times more effective than carbon dioxide at trapping heat in the atmosphere over a 100-year period. Municipal solid waste landfills are the third largest source of human-related methane emissions in the United States.
The DEP estimated that about a third of landfill space is occupied by organic material, which is, we really ought to save landfills for the stuff that we just don't know what to do with elsewhere.
So clearly, putting food scraps into landfills is bad for the environment, and exacerbating climate change is not what humans should be doing right now. So what if, instead of throwing those 133 billion pounds of waste into the trash can each year, we composted them? Here at Dickinson, that is exactly what the college farm is doing.
So we start with the food waste from the cafeteria. Every day the dish room workers take all the unserved food and scrape it into the Hobart, and then we also have all the trimmings from the kitchen and things that spoil in the kitchen, things like that. So it's really both post-consumer and pre-consumer waste. We get between 500 and 1,000 pounds of food waste from the cafeteria every day. So I usually say about an average of 700 pounds a day. What we do, we pile up the food waste and the leaves and wood chips in what's called a windrow. It's like a long ridge type pile, and we just pile them and pile them and pile them, and once we've collected enough to make one long windrow about 100 feet long, then we'll start turning that pile, and we turn it usually about 2 or 3 times over the course of a year. Turning it adds oxygen into the compost pile. It takes stuff that was on the outside not getting composted and mixes it into the inside of the pile. It also reshapes the pile and it aerates the pile, giving the microbes oxygen, which helps them do their job. As an organic farmer, we rely on healthy soil to help make our crops grow. And we don't have a lot of the conventional tools that other farmers would have for doing pest control, disease control, and such. So it really is important that our soil is in good shape such that our crops are healthy and then they require less outside inputs. Also, we need nutrients for our crops to grow. So compost provides those services for us. We can generate a healthy soil food web by starting with adding organic matter to the soil and adding organic matter that's microbially rich and available. So compost is a good part of that. When you add organic matter to the soil, it creates water holding capacity, and it also creates drainage and nutrient holding capacity. And it just diversifies the microbial profile of the soil. So we see our soils started off as about 2% organic matter, and we're gradually pushing them up to 3% organic matter, and we attribute some of that to the compost.
Applying compost to cropland is one of the most beneficial things a farmer can do for their soil. The application of compost has been shown to suppress weed growth, it acts as a natural organic fertilizer, and it increases the soil organic matter. Compost helps soil retain anywhere from 30 to 70% more water than land that doesn't have compost on it. When soil can't retain water, it is difficult for crops to grow, and during extreme rain events, the water runs off into local waterways instead of permeating the soil profile. This often leads to harmful algal blooms in aquatic ecosystems. This water retaining capacity is essential to encourage as climate change is leading to droughts in many parts of the world. But what is truly most fascinating about compost is its ability to promote one of the most fundamental natural cycles on this planet, the carbon cycle. Soil is a carbon sink. This means it has the ability to take atmospheric carbon and store it beneath our feet. When compost is applied to land, it helps boost soil health and its ability to sequester carbon. Today, there is too much carbon in the atmosphere, so finding ways to reduce this number and promoting carbon neutrality are essential in mitigating climate change.
The college farm is, I think, one of Dickinson's truly unique sustainability distinctions. Compost is understood as a carbon sequester. It mitigates carbon. It basically pulls carbon out of the air. And so our compost operation, in addition to reducing landfill waste, because all that food waste would have gone to the landfill otherwise, which has very negative environmental associations, but it also mitigates carbon. I think at this point we're mitigating about 40 metric tons a year of carbon because of our compost operation.
Between 2010 and 2015, the college collected 1,619 tons of organic waste, offsetting 641.3 metric tons of carbon dioxide through the compost operation. Now think about this on a larger scale. If one small school with 2,356 students can do this, imagine an entire city composting, or even the entire country. It all goes back to the individual. Next time you cook a meal, instead of throwing your food scraps in the garbage, set them aside in a plastic bag. You can even put them in your freezer to store. Find a farmer's market, curbside pickup location, or farm that you can bring it to, and watch your food scraps transform.
I think compost is a great opportunity to expose how human beings can sort of start to work more in concert with nature, with sort of natural and sustainable sort of environmental systems on the planet.
Compost is nature's version of recycling. It just happens. There is something enchanting about it. Watching something as mundane as an eggshell or a rotten apple transform into something so rich and valuable. Compost has the ability to change the way we view waste. It has the ability to sequester carbon and help mitigate climate change. It has the ability to bring degraded soil back to life. It provides nutrients to the plants that humans rely on for survival. If everybody composted, we would be living in a different world.
So compost is fun, it's easy, and it's forgiving. It's really a simple thing you can do to help the environment. And we appreciate people participating in the Dickinson College composting project.